Hello and welcome to another video. In this video we're going to be working on take k of each character from left and right. And I've already done this one before, so we're going to do it in the review format this time. So here you have a string s consisting of ABC and a non-negative integer k. Each minute you may either take the leftmost character or the rightmost character and return the minimum number of minutes needed for you to take at least k of each character, or return -1 if it's not possible. So in this first example, you're going to take 3 from the left and then 5 from the right. So that'll take 8. So this number of minutes is basically like you can take some subarray from the right and some subarray from the left, and then return the minimum length of like both of these combined. And in this case, there are no B's and C's, so you can't do anything. So you can do like a count of every character to make sure there's enough of each to start if you want to. But this problem is kind of similar to another one that we had like a week ago or something, where essentially you can have 2 windows of like elements and you want to just figure out like what's the best combination. And notice that, like, let's take a look at this example here. So let's just write down these characters. So like A, B. We can even make this a little shorter. So let's just say we have this. This is like our characters. So we can figure out like how many we want to take from the left and how many we want to take from the right. And as we take more from the left, we can shrink how many we take from the right. So we can start off just saying, let's just take nothing from the left and let's just take as many as we need to from the right to satisfy this like thing equals k. And that part's pretty easy, right? Just like what's the length of a subarray from the right that you have k of each character. You can just do like a count and then get that. So basically you're going to go all the way to here. You're going to need to take this many characters to get 2 A's, 2 B's, and 2 C's. And this is going to be like our initial solution. So here, nothing from the left, and then 2, 4, 6, 8 characters from the right. And now what we can do is we can basically start taking characters from the left. So we can maintain a count here. So we have 4 A's, 2 B's, and 2 C's. And we can start taking characters from the left. And then for every character we take from the left, we're going to see if we can shrink our right to still maintain this like k equals 2 thing. So in this case, k is 2. So we're going to start with this character. We're going to say, if we take an A here, can we shrink the right? And how do we know if we can shrink the right? Well, whatever character is on the right, the total from the left and the right needs to be greater than k in order to get rid of this character. So the total from the left of B is 0, and the total from the right is 2. So we can't get rid of this character because we still don't have enough. Like, we're only going to have 1, so we can't do it. So we keep going from the left. So we're going to add another character. And can we shrink the right? No, we still can't shrink the right, because we need to get 1 more B. And then once we get to this case, we're going to have an A, we're going to have a B here, and 2 B's here. And now we have an extra. So because we have an extra, we can shrink the right. So we're going to shrink the right. Now we have 1 B. And we're going to keep shrinking the right as long as we can. So can we shrink A's? We have 6 A's total, and we only need 2. So we can shrink these 2 A's, and now we'll have 2 A's. And can we shrink it anymore? No, because we only have 2 C's, so we can't get rid of a C. So now this is our current solution. So we're going to take this much from the right and this much from the left. So notice we're basically moving the left up, and then every time we move the left up, we just say, can we shrink the right? So the right is always going to go this way, and the left is always going to go this way. So it's basically like a 1 pass. So here, our solution is 5 and 3, so that's 8. And I think that's actually what we already originally had, but in this case, this one had more A's. So this is still the same. But if we had more A's, this would be less, right? Like it would start off as 10 and then go to 8, like in this example. And we keep going. So if we add an A here, can we get rid of a C? No, because we only have 2. So if we add an A here, can we get rid of a C? No, because we only have 2. Then we add a C here. Can we get rid of a C? Yes. So we're going to shrink. Can we get rid of an A? Yes. Can we get rid of another A? Yes. So now we'll have 0. Can we get rid of this B? No, because we only have 2 B's. So then we're going to add these 2 A's, and we can't shrink until we get to the next B. So now we have 2 B's. And as we keep doing this, we're just gonna track, like at every iteration, we're gonna track like how long is our left, how long is our right, and minimize our result. So yeah, so we have 2 B's and 1 B, so we can shrink. And yeah, like in this case, for example, there'd be 1 number from the right and 9 from the left, so that's worse. And then one more time, we can't shrink anymore because we have to have the 2 C's. And then finally, the last one, we'll have 2 C's here, and then we're gonna be able to shrink from the right. So our right will just go out of bounds. That's like our last thing. And here, yeah, so our best was 8. So that's the basic idea, is you start with nothing from the left, and you keep going right until you have k of each. And then as you keep taking in elements from the left, you're going to shrink from the right. And then you're just going to add every single iteration. You're going to take in elements, shrink, calculate the total. And that's the basic idea of this problem. So let's take a look at the code. So essentially I just made a count of A's, B's, and C's for the left and for the right. And I just check while the right count of every single element in the right is less than k, let's just keep growing out the right. And if we went through the whole array and didn't get a count of k, right? So like let's say we take nothing from the left and we take everything from the right and we still don't have k, that means there is no solution, so we should return -1 here. Then we initialize our result to however many we took from the right as like our default, and then we do the same thing from the left. So we start from 0 from the left, we're going to take in a character, and while we can remove from the right, let's remove from the right, and then just minimize our old result plus. So the total calculation here is basically like how many elements are we taking in from the left? That's going to be the left index plus 1, right? Like here we're taking 2. In this case, we'd taken 3. And how many elements are we taking from the right? That's going to be the length of the array minus right, I think. So the length of the array here is 10, and we're taking in 4, so 10 minus 6. So the whole total is left plus 1 plus length minus right is like how many you take from both sides. So that's why I have this. And then we just return. Yeah, submit that. And you can see it's pretty good. So yeah, it's kind of like not one sliding window, but you can realize like I can just maximize one, and as I grow one, the other one only shrinks. So this will be linear, and space is of 1 because we just have 3 for each one of these, only A's, B's, and C's. So of 1 space. And yeah, it's gonna be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.